done. So what happens to that water droplet which is falling on lotus leaf? It rolls off, right? So it rolls off because this lotus leaf, it is having some small bump-like structures, okay, which creates a high surface angle between the droplet and the surface. Okay, so you can clearly observe here. So thus that has inspired for the invention of see here, you can see here when water falls on this lotus leaf, what is happening? That water clearly rolls off, okay, on the water that is on the leaf surface. Okay, it clearly rolls off, and you can see no water droplet will be found on that leaf. Okay, so that has inspired for the invention of self-cleaning surfaces. Okay, and super hydrophobic surfaces. So this property of lotus leaf, okay, so which is repellent to the water. Okay, so if any droplet which falls on this lotus leaf, it rolls off easily. Okay, and it cleans whatever the dust particles which is residing on that lotus leaf. Okay, so that has inspired for the invention of super hydrophobic. Srushti ಏನು ಬರೀತಿದೆಮ್ಮ? So that has led for the invention of super hydrophobic surfaces and self-cleaning surfaces. Okay, so what is the difference between a normal surface and a lotus surface? As I said, this lotus leaf surface will be having some nanostructures that is called, we call it as bumps, okay, with a tiny hairs on it. So you can observe here. So you can observe in this upper diagram, okay. So this is the surface of lotus leaf, which will be having small bumps, okay, with a tiny wax coated hairs. So these structures has made the lotus surface is different from the other surface. Okay, so when the water, when it is falling on this lotus surface, it clearly rolls off. Okay, and along with this, it also takes all the whatever the dust particles which is sitting on that surface. Okay, so because these bumps, it creates a high surface angle. This is, you can observe here clearly the normal surface and the lotus leaf surface. So when a normal surface, when the water falls on the normal surface, there will be a friction. Okay, friction between that water droplet and the surface. Okay, so it cannot wash out all the dust particles which are sitting on that surface. Okay, but when the water falls on this lotus leaf, you can clearly observe due to these bumps. Okay, there will be a high surface angle which will be created between the water droplet and the surface. Okay, which will be more than some 150 degree. Okay, so like this, the surface angle between the water droplet and the surface will be more than the 150 degree. Okay, so making it as an super hydrophobic in nature. Okay, super hydrophobic means it repels the water and that water rolls off very easily on that surface, and along with it, it takes whatever the dust particles which is residing on that surface. Okay, so that is what so this effect, this we call it as lotus leaf effect. Okay, so the lotus leaf, so whatever the water droplets which is falling on the lotus leaf, it can roll easily. So along with it, it takes all the dust particles which is residing on that lotus leaf. Okay, so this effect has led to the invention of super hydrophobic surfaces and also self-cleaning surfaces. Okay, as the name itself indicates, self-cleaning surfaces means, so when they are super hydrophobic in nature, it repels the water as well as it cleans that surface. Okay, so it cleans automatically, so no manual intervention is needed to clean those surfaces. Okay, so that is what super hydrophobic effect, this super hydrophobic effect, which has the mimicking the effect of lotus leaf. Okay, so which mimic the effect of lotus leaf, and so these super hydrophobic surfaces, they will be coated with certain chemicals. Okay, so that if any water or if any oil, anything, if any liquid which is falling on that surface, okay, so it rolls off very easily, and also it cleans those surfaces automatically. Okay, so this has introduced this super hydrophobic and self-cleaning surfaces as introduced in the automobile industry. Okay, so if you take the car glass, okay, anything, so if this if those things are coated with these super hydrophobic chemicals, okay, then so automatically they clean those surfaces. Okay, so no manual intervention is required. Okay, so this, what is the main speciality of this lotus leaf? As I said, so if no bumps on that lotus leaf, then the friction between the water droplet and the surface will be more. Okay, so then the water cannot roll easily. So due to this bump along with the tiny airs, okay, so those structures are creating the high surface angle between the droplet which is falling on that surface. Okay, so when there is a high surface angle created, so then water can roll easily and it cleans the surface automatically. Okay, so that is what. And what is the difference between the normal surface and the lotus leaf? This is what the small bump-like structures. There are the nanostructures which are found on the lotus leaf. Okay, and so this is what the when the surface angle, when it is created, when it is behind 150 degree, so it makes that surface as a super hydrophobic. Okay, so it can repel the water and also it can clean that surface automatically. Okay, so that small bump like structures, they are creating the high surface angle in the lotus leaf. Okay, so this is about moving from hydrophobic to super hydrophobic. Okay, so those nanostructures are creating a high surface angle, so which is making it as super hydrophobic in nature. And as I said, so when we want to mimic the lotus leaf effect, okay, so then those surfaces will be coated with certain materials, okay, like fluoropolymers, silica-based nanoparticles, carbon-based materials, and the metal-based materials, polymer-based materials, natural materials, and the hybrid materials. So when those surfaces are coated with these kind of materials, you can convert it into hydrophobic into super hydrophobic in nature. Okay, so and what are the process? So these are the process to create a super hydrophobic surfaces. So that is the chemical vapor deposition and solution and gel method. Okay, and electrochemical methods, plasma treatment. So treating the surfaces with the plasma, as well as micro and nanostructuring techniques. Okay, so creating the nanostructures on the surface so that it can create an high surface angle, and also the chemically modifying those surface with coating with certain chemicals. Okay, so these are the few techniques in order to convert a surface into hydrophobic into super hydrophobic in nature. Okay, and what are the applications? As I said, so the lotus leaf effect has led for the invention of these super hydrophobic surfaces. Okay, and what are the applications? So it is used in the electronics industry. So you can see there are many display boards which will be hanging in the outside in the nature. Okay, and those display boards will be kept there itself when the rain is coming. Okay, or during the fogging. So those surfaces, the display board surfaces will be coated with the these super hydrophobic materials, so that when the water falls on it, so water will not water will roll off very easily. Okay, and those surfaces are water repellent surfaces. Okay, those are coated with this super hydrophobic materials. Okay, and moisture resistance, self-cleaning displays. As I said, so when the display boards or when the electronics, okay, so all the electronic equipments, these are waterproofing equipments. Okay, when the water falls on those equipments, it rolls off easily. Okay, so and anti-fogging windows and mirrors. So we have observed during the winter season, during the November, December, and January. Okay, there will be heavy fog outside. Okay, so when we want to travel from one place to another place, definitely, so the fog will reside on the glass. Okay, so when the glass, when it is coated with these anti-repellent surfaces, okay, or super hydrophobic surfaces, then whatever the water droplet which is created, and which can roll off very easily with the help of these super hydrophobic surfaces. Okay, and self-cleaning surfaces, as I said, so it is used in the clothing industry, okay, fabric industry. So certain cloths are also super hydrophobic in nature. When the water falls on them, okay, so the water rolls off very easily. Okay, and fuel efficiency. So these super hydrophobic materials, when they are used in the automobile industry, okay, which can increase the efficiency of that particular automobile. Okay, yeah, no, last Mahindra, come here. Dinesh, you go to last page. I answers ನೋಡಿದ್ರೆ ಬಾಯ್ ಪಡ್ಕೊಬೇಕು. And it is also used in the aerospace industries. Okay, and which will be useful for the drag reduction. Okay, so in the aerospace, so when the aeroplane is moving, okay, when the aeroplane is coated with these hydrophobic materials, okay, so it can reduce the drag and it can increase the efficiency of that plane. Okay, and also fuel efficiency will also be improved. Okay, so these are the some of the applications of these super hydrophobic surfaces, okay, which is mainly used in the automobile industries, aerospace industries, and self-cleaning materials. Okay, so the main idea behind this is what we have observed in the lotus leaf effect. Okay, so when the water, when it falls on that lotus leaf, it can easily roll off. Okay, because that lotus leaf will be having some small bump-like structures. Okay, so when the water falls on those bumps, so it can roll off easily because those bumps will create a high surface angle. Okay, high surface angle between the water droplet as well as that surface on which that water is falling. Okay, so this has led for the invention of the super hydrophobic materials. Okay, which is mainly used in this automobile industries and electronic gadgets. Okay, and the display boards which will be hanging outside. Okay, and any electronic equipment which will be hanging outside, okay, which will be drenching in the rain. Okay, so those will be coated with this super hydrophobic that is material.